This is the Math 236 Applied Calculus for Business and the Social Science. Today, we will talk about the midterm review. We will review Chapter 3 and Chapter 4. I'm going to talk about the similar question to the midterm exam. First question, a company manufactures fuel tanks for cars. The total weekly cost in dollars of producing X tanks is given by cost function C of X equal 10,000 plus 90x minus 0.05x squared. A. Find the marginal cost function. Marginal cost function is the first derivative of the total cost. So total cost function C of X take first derivative at prime of X equal to 10,000 is a constant. The constant take derivative is 0. Then add 90x take derivative is 90 times 1 x to the power 1 minus 1. So will be 90 x to the power 0. X to the power 0 is 1, so it's 90. Minus, use the power rule of derivative. X to the power n, take derivative, prime, is equal to the n go from n times x to the power n minus 1. So 2 times 0.05 times 2 times x to the power 2 minus 1. Then 0.05 times 2 is 0.1 times x to the power 2 minus 1 is x to the power 1. So this is the marginal cost function. Find the marginal cost at a production level of 500 tanks per week. So you plug this x is equal 500 tanks. X is how many tanks? So x is 500. Plug in x in marginal cost function. So we'll plug in 90 minus 0.1 times 500. We'll get 90 minus 50, get 40. So this is per tank is $40 at production level, 500 tanks per week. Per week, because here's a weekly cost. And the C, find the exact cost of producing the 500 first tank. So producing 500 first tank, the cost is total cost of 501 tank minus total cost of 500 tank. And then you will get the 500 first tank cost. So you will do 501 plug into the total cost function. Is going to be 10,000 plus 90 times 501 minus 0.05 times 501 parentheses square. Then minus and use the bracket 10,000 plus 90 times 500 minus 0.05 times 500 square. Then remove this parenthesis, change plus to minus change to plus, plus change to minus, minus change to plus. Then 10,000 with this 10,000 subtraction is 0. Then 990 times 501 with minus 90 times 500. Fact put together the two term group. Use bracket group. Then the two term, and we put the plus first, plus this term 0.05 times 500 squared minus this term 0.05 times 501 squared, and group together. Use bracket. Since here is a plus, then minus, so here still minus, don't change the sign. Then 90 factor out, 501 minus 500 is 1. So 90 times 1 is 90. Then common factor 0.05 factor out, and remain 500 squared minus 501 squared. Then this, you will use a squared minus b squared equal a minus b times a plus b to factor. A is 500, plug in. B is 501, plug in. You will get 500 minus 501 times 500 plus 501. Then 90 plus 0.05 times 500 minus 501 is a negative 1. Then 500 add 501 is 1001. Then 0.05 times negative 1 times 1001 is 50.05, and subtract from 90. So the answer is $39.95 when produce the 501st tank. The exact cost is $39.95. And if we use marginal cost, which is at 500 tanks, then increase by $40 after 500 tanks produced. The next tank take derivative, that means first derivative of cost function at the 500 level. That means the increase rate, because positive. So after $500, 500 tanks produced, then produce one more tank at a production level 500 tanks. The cost is $40 per tank. This is what we call instantaneous rate of change. Per tank increase by $40. So that means at 500 first tank, cost due by the first derivative is $40, but due by the subtraction, it gets $39.95. The two are very this is exact cost, very close to each other, exact cost, and this is use instantaneous rate of change to do. Get $40. They are very close to each other. And question 2, a company market research department recommends the manufacture and marketing of new headphone. After suitable test marketing, the research department presents the following price demand equation. This is a demand equation. It's X equal 10,000 minus 1,000 times P. Here the X is the demand, X units is given as a function of the price. P is the price, where X is the number of headphones that retailers are likely to buy at $P price per headphone. And the financial department provides the cost function. Cost function is C of X equals 7,000 plus 2X. 7,000 is the estimate of fixed cost. For example, like a rental fee, like a touring or overhead fixed cost. And the $2 is the estimate of variable cost. Per headphone is $2. And like make a headphone need materials, labor, marketing, or transportations or storage. Per headphone cost is $2, and total have X headphone. So the cost is 2 times X. And then add together, variable cost add fixed cost is the total cost function C of X. A, express the price P as a function of the demand X and find the domain of this function. So this is X, this is a demand function, X in terms of P. Now once you write P in terms of X, so we solve for P. X equals 10,000 minus 1,000 P. If we move this term to the left side and change minus to plus, become 1000 P equal. Move this X term to the right side, change the sign, become minus X. So in 10,000 still on right side. So the equation become 1000 P equal 10,000 minus X, because we want to solve for P. So I make P term on left side, X term on right side, separate. So then divided by 1,000 each term. 1,000 P divided by 1,000, 1,000 cancel, get P equal. 10,000 divided by 1,000 is 10 minus X over 1,000. And this is the price P as a function of X. And want to figure out this domain. Since the price is a positive, will not be negative. So then we let this P greater than or equal 0, positive or equal 0. In other words, it's 10 minus X over 1,000 greater than or equal 0, because P equal 10 minus X over 1,000 and P greater than equal 0. So this, the right side should be greater than or equal 0. And solve for the X, get the domain. So you do times by 1,000 each term. 10 times 1,000 is 10,000 minus times by 1,000, cancel 1,000, get X greater than or equal. 0 times 1,000 is 0. Then add X both sides. The quick way is move X to the right side and change the sign. Minus change to plus. Get X. So this is 10,000 greater than or equal X. And rewrite is this side is the pointer, is a smaller side. So X side is smaller. So rewrite is X less than or equal 10,000. And since X is units, how many number of headphones? So it's impossible. Negative number, always greater positive or 0. So the domain is X greater than or equal 0 and up to 10,000. This is, you can write this way. Interval notation from 0 up to 10,000 and including 10,000. That's the interval notation for the domain. B, find the marginal cost function. cost is C, total cost function is C of x equals 7,000 plus 2x. Marginal is the first derivative of it, which is instantaneous rate of the change of the function. We call marginal cost function. So we cost function take first derivative. 7,000 constant take derivative is 0. Plus 2x take derivative is 2. So this side is 2. This means since this is constant, this is constant, so it costs an additional $2. Here's 2 to produce one more head form at any, because always constant. So at any production level, that means x, like x is 1,000, is still rate is still 2. If x is 2,000 and is still 2, x is 3,000 is still 2. So x is the how many head form produced. So at any production level, x, the increase rate for the cost is always constant, $2. So it is constant. So cost an additional $2 to produce one more head form at any production level. And C, find the revenue function, and the states is the domain. The revenue is the price times x times how many demand, which is how many sell out is demand, how many want to buy. So it's x is how many head form times p. P is the price. So it's x times p. P is the price. And p we already find over here, 10 minus x over 1,000. So put the parentheses and the distributive in equal 10x minus x distributive in. Get x squared over 1,000. And this is the revenue function. And find the domain of it. Since the revenue is how many dollars, is the money income, so is it impossible, negative. So we let this revenue function r of x greater than or equal 0. And the x is how many head form is not possible, negative. So x is also greater than or equal 0. In other words, revenue function is x times parentheses 10 minus x over 1,000, this one greater than or equal 0. Since x is positive, so you divide both sides by x, so you will get 10 minus x over 1,000 greater than or equal 0. And solve for the x is the same way as this one. You times by 1,000, so get 10,000 minus this times 1,000, cancel, get x greater than or equal times 1,000, 0 times 1,000 is 0. And move x over, change the sign, get x on the right side. So the 10,000 greater than or equal x. That means x less than or equal 10,000. So you answer the domain. Domain is the same as A. So domain is from 0. You can put interval notation from 0, comma to 10,000. That's interval notation. You can answer either way. That's C. Question 2. D. Find the marginal revenue function. Revenue function is this one, 10x from C. From C, we got revenue function is r of x equal 10x minus x squared over 1,000 from C. Then you take first derivative of this revenue function. So r prime of x equal 10x, take derivative is 10, minus 2 go from 2 over 1000 x to the power 2 minus 1. So equal 10 minus 2 and 1000 cancel. So you got 2 minus 1 is 1. So it's x over 500. And find the marginal revenue at x equal 2,000, 5,000, 7,000. Interpret these results. So we will find r prime of 2,000. R prime, take first derivative. R prime of x is from D, is this one, and use 2,000, plug in, and get 10 minus x is 2,000 over 500, and cancel 2, 0. 20 divided by 5 get 4. 10 minus 4 get 6. Then interpret the result. So at production level, 2,000 headphones units, 2,000 units. The revenue, because 6 is a positive, so it's increase. The revenue increase at the rate of $6 per unit per headphone as production increases. Production increases, then the revenue increase per unit is $6. Then figure out R prime of 5,000. So you plug 5,000 into x. So get 10 minus 5,000 over 500. Cancel to 0. 50 divided by 5 is 10. Get 10 minus 10, get 0. That means interpret the result. At production level, 5,000 units, revenue does not change with a small change in production. If you increase by 1 unit, 1 headphone, you produce 1 more headphone, then the revenue doesn't increase. Your income doesn't increase at 5,000 level production. And the third one, find out R prime of 7,000, and so you plug in 10 minus 7,000 over 500. Cancel. 70 divided by 5 is 14. Then 10 minus 14 is a negative 4. It's a negative. So at a production level, 7,000 units, the revenue decreased because negative. So it's a decrease, and this positive increase. At the rate of $4 per unit as production increased. You increase 1 more, you produce 1 more headphones, then the revenue will decrease by, your income will decrease by $4. The next one is F. Find the break-even point. Break-even point. Break-even point is your cost and your revenue are equal. That means you don't have any profit. You don't lose, and you don't gain. The cost and the revenue are equal, and that means you don't have any you don't lose any, and you don't gain any. So is you let the cost function C of x equal R of x. And solve for the x. Get break even point. Break even point. X common C of x. You can put C of x is equal R of x. So you can put R of x here or C of x. That's the point. So C of x is 7,000. Cost function is 7,000 plus 2x equal. Revenue function is 10x minus x squared over 1,000. This is come from C. Come from C. Then put equal. Put equal. First of all, you have to put the in descending order in the standard form. So this is the x squared term. Put first. Here minus, move to the left, change the sign, become plus. Put the first, x squared over 1,000 first. Then this 10x, move to the left, change the sign, become minus 10x. And here 2x on left side, so don't change the sign, press 2x, and then press 7,000 equal. Since the right side, all the two term moved to the left, so right side is become 0. This is a quick way to do. You can do subtraction property, addition property, and move the two term to the left. Then combine like term. This two term like term combine. So it's x squared over 1,000. 10x negative plus 2x is a negative. Ax plus 7,000 equals 0. Then remove the denominator. So times by 1,000. 1,000 cancel, get x squared. Times by 1,000, so put 3 more zeros, get 8,000x plus 7, and plus 3 more 0 times 1,000, and equal 0 times 1,000 is still 0. And factor this. And you need to find two number times together is 7 million, and the two number add together is 8,000. So will be negative 1,000 times negative 7,000 is a positive 7 million. That's two number timed together is 7 million. And the two number negative 1,000 add negative 7,000 add together is a negative 8,000. So you got the two number is negative 1,000 and the negative 7,000, and put a factor like this. You can check it. X times x is x squared. FOIL. Outer term product negative 7,000x combined with the inner term product negative 1,000x is a negative 8,000x. The last term product negative times negative become positive. 1,000 times 7,000 is 7 million. And so the two are equivalent. Then the two factor timed together equals 0. Then either first factor equals 0 or second factor equals 0. And then you let x minus 1,000 equals 0. Solve for the x. X will be 1,000. And let x minus 7,000 equals 0. Solve for x. X will be 7,000. So there is a two break-even point. One is when x is 1,000. Then you can plug into cost function, or you can plug into revenue function. Because here at the 2 points, the cost and the revenue are equal. So it doesn't matter which one. If you put cost is easier to do because you don't need to do square. So put into cost function 7,000 plus 2 times 1,000 get 9,000 is the cost. And 7,000 plug into cost function, 7,000 plus 2 times 7,000 add together 14,000 at 7,000 is $21,000. So put down break-even points are when the x is 1,000 units, the cost or revenue is $9,000. Another break-even point is when x is 7,000 units, and the cost or revenue are it's $21,000. So break-even points is let cost function equal revenue function and solve for the x. And G, find out the profit function. Profit function, profit is revenue. Revenue is money, income. You sell the product and you got the money come in, but you have subtract the cost, your cost, and you will get your net profit, P of x, that profit function. So your net profit is your revenue, is money bring in, your income, minus your cost. So revenue is 10x minus x squared over 1,000 minus the cost. And cost here you need to put the parentheses because here's minus. Since you remove the parentheses, this plus have to change to minus. Then combine like term. Put the x squared term, highest exponent first. Highest degree square first. Negative x squared over 1,000. And the 10 minus 2x is 8x. Then minus 7,000. This is a profit function. Then find the marginal profit function. So you do profit function, take first derivative. So it will be this one. Here has a negative. And 2 go from 2 over 1,000 x to the power 2 minus 1 plus ax. Take derivative is 8. Constant term take derivative is 0. Then cancel common factor 2. Got 500. So you got negative x 2 minus 1 is 1. X over 500 plus 8. This is a instantaneous rate of profit, which is what we call marginal function. It's the first derivative of the profit function. Then find the marginal profit at x equal 1,000, 4,000, and 6,000. Interpret these results. So you plug into this marginal profit function, x use 1,000, plug in 1,000 at p prime of 1,000 equal negative x use 1,000 over 500 and cancel 10 over 5 is a negative 2, add 8 is a 6. Then explain it. So it means at 1,000 units output level or production level, the profit will be, because positive 6, so it's increased at the rate of $6 per unit. If production is increased. So that means each time if at 1,000 units have formed, output level, if you produce 1 more units or you sell 1 more units, then your profit will increase by $6. And P prime of 4,000 and plug into this function is negative 4,000 over 500 plus 8 and cancel 2 0. 40 over 5 is a negative 8 plus 8 is a 0. So that's interpret. At 4,000 head forms output level, the profit does not change for small changes in the production. If you increase by 1 unit of head form, then at a 4,000 level of production, your profit doesn't change. And at 6,000 units, x is 6,000, plug in 6,000 over 500, cancel to 0. 60 divided by 5 is a negative 12 plus 8 is a negative 4. It's a negative. So at 6,000 units output level, profit will be decreased because it's negative. We call decrease at the rate of $4 per unit. if production is increased. Production increased, the profit is decreased. Production increased by 1 unit, and the profit decreased by $4. The next one, find the average profit function. Average profit function, we use P bar, P hat, P bar of X equal. Average is profit is P of X divided by X units. That's per unit. How many profit? That's what we call average profit function. So divided by X. So then this first term, this is a profit function. We find from previous one, from G, profit function from G, divided by X. So first term divided by X. Second term, 8X divided by X. Third term, minus 7,000 divided by X. And this cancel X. Okay, negative X over 1,000 plus X cancel, plus 8 minus 7,000 over X. This is the average. Per unit, how much profit? Okay, the average profit per half form if 1,000 half forms are produced. So the X equal 1,000. So P bar of 1,000 equal, plug into this function, net X use 1,000 plug in over 1,000 plus 8 minus 7,000 over 1,000. So we got cancel, get -1 plus 8 minus those 3, 0 cancel. So we got -7, add together is 0. So the average profit per half form is 0 at 1,000 production level. It's 0. There's no average. The average profit is 0. Then marginal average profit function, which is this average function take derivative. This function take derivative. This function take derivative. First of all, we have to use negative exponent rule. Change this denominator on denominator x, move up to the numerator, x power to the power 1. Use this negative exponent rule. X to the power n, if you move up to the numerator, is x to the power -n. So it's become 7,000 times x to the power -1. This one, use negative exponent rule and change to, because this is a 7,000 over x, move this up, is a 7,000 times x to the power -1. Change the sign, negative exponent rule. And here is still 8, and here is a -1 over 1,000 x. And marginal is to take first derivative. Take first derivative on this average profit function. So it's a -1 over 1,000, and then x to the power 1 minus 1 is x to the power 0 is 1, so it's this one. And the plus 8 take derivative is 0 minus -1 times -7,000 is a become minus 7,000, and this one take derivative is a -1 x to the power -1 minus 1, and this -1 over 1,000, this negative times this negative become positive 7,000 x to the power -1 add together is a -2. Then use negative exponent rule. Bring this term down to the denominator. -2 change to +2. So right, this is the final answer. That's marginal because the first derivative of it. And find the marginal average profit at production level 1,000 forms. So you use x, use 1,000 plug in. 1,000 plug in into marginal average profit. So is marginal average profit function is this one. So the net 1 over 1,000 plus 7,000 over x, use 1,000 square. And get net 1 over 1,000 plus 7 over this. And those is 3 0 cancel. It remains 7 over 1,000. And then 1,000 is net 1, add 7 is 6. And 6 over 1,000 is a move decimal point from 6 and move to the left 1, 2, 3 positions. Got 0.006 attach percent sign. Because here is 6 zeros, so you decimal here 1, 2, 3. 3 zeros, so move 3 position to the left. Attach percent sign. Not attach percent sign, I'm sorry. Is 0.006 is dollars. Now then, use the result from parts K and LM, KLM to estimate the average profit per head form if 1,001 head form are produced. So P average, P bar of 1,001 is approximately equals P bar of 1,000 plus P first derivative. Because P, this is the average profit at 1,000 level, is 0 per head, $0 per head average profit at 1,000 head phone levels produced. The average profit is per head is $0, and then the rate increased by one units, then the average profit increased by $0.006. That's marginal average profit, which is per head phone. Will be average each phone increased by $0.006. So 0, this 0 per head phone profit is $0. Add the increase rate for each head phone produced, then the profit is $0.06 add together. So the average profit per head phone at 1,001. So 1,001 head phone are produced. The average per head phone, the profit is 0.006. That's the average profit. Now, then question 3. The total sales S in thousands of gains of a video gain, GAME, video gain. T months after the gain. T months after the gain is introduced are given by this. This is sales, total sales. How many gains? This is in thousands of gains, is this function. First of all, find S prime of T, first derivative. And you will use quotient rule. The quotient rule, because this is a quotient. So use quotient rule. The quotient rule is f numerator over denominator take derivative. That's equal to denominator square. Numerator take derivative times denominator do not take derivative minus numerator do not take derivative times denominator take derivative. This we call quotient rule. So denominator square, so is take derivative is denominator square, g square. G is t, denominator is t square plus 100 square. Numerator f prime, this is f, this is g. So 125 t squared, take derivative is 125 times 2 t to the power 2 minus 1 times denominator g times denominator t squared minus 100 minus f, where f is numerator, 125 t squared times g prime, denominator take derivative, t squared take derivative is 2t, 100 take derivative is 0. So this is g squared, and this is f prime times g minus f times g prime. That's a quotient rule. And then we just simplify it. This 125 times 2 is 250. T, 2 minus 1 is t to the power 1 times parenthesis t plus 100 minus 125 times 2 is 250 times t squared times